Are you observing in this photograph? Just keep some time for it. Should I rotate it? Should I rotate? Okay, now this is wrong one. Like what are you observing in this photograph? Just tell me, someone should tell.
Convoluted lamination.
Huh? Convoluted lamination, huh? Anybody?
Folds.
Folds. And what else? So this is a folded out. I was seeing so many folds. What is there you are thinking? Huh? From a distance you can see there are so many folds. You see? So many folds. Have you seen, huh? Very beautiful outcome. Some people see beauty in the rock. So one day, someone told me, you have lost your aesthetic sense. so it's a very beautiful folds, you know. Now, but very complicated thing also are there, you know. Externally it looks okay. But if we just ask you, the fold is developed on what? Which has been folded? What has been folded? You don't understand my question, no? Folds are there fine. But suppose somebody asks you, what has been folded? What is the surface or what is the structure which has been folded? That is very difficult to answer. See, somebody says, you know, this is a white layer, you know, which has been folded. Can you see, no? And this, can you see these things? Very close space, white dark layers. Can you see, no? They are also folded. So what is this white layer? What is this white and dark layers? What is this white layer again? This is a very big white layer. What are those things? So just keep this photograph in mind. I'll go to another photograph. I'll come back again. It's like little enlarged view, you know, very close view. You can see these folds, huh? Can you see this fold, this fold, this fold? Here also there are folds. Here also there are folds, you know. So what has been folded here? That is what we decided. Then only the next part of discussion will be fruitful. Now suppose I ask you to break this rock. तो rock कैसे break करेगा? Which portion will be easy to break? This portion will be easy to break or this portion will be easy to break? Huh? See, here also there are folds. Here also there are folds. Suppose I ask you to take a sample from this outcrop. आप किधर तोड़ेंगे? किधर तोड़ेंगे आप बताओ? इतना बड़ा आउटक्रॉप है, from 5 meter by 5 meter, maybe, you know, 2 meter by 2 meter. You know. This is for scale, huh? So which part will break? Definitely will break this part, you know. Because these layers will help you to break the rock, isn't it? These layers will help you to break the rocks. Here if you break, you know, the layers are not so close spaced. Thick layer, thick layer, thick layer. Here the rock will break very easily. Here the rock will break so easily. Rock will break very easily. Understood, na? If that is the case, I ask you, along which surface it breaks? Along which surface the rock breaks? Follow this point. What I am asking. The rock will break the most weak plane along the weakest plane. Na? The weakest plane in a folded rock is the cystosity plane. Remember, this is the cystosity plane or the foliation plane. You know. Foliation plane or the cystosity plane. You forget about the folds. You go to an area like Aravalli or Eastern Ghats. Anywhere, you know, India where there are rocks are deformed, metamorphosed, and you try to break a rock. Understood? Now, see, the tendency for you, you know, will go for a weaker plane. The rock will break along the weakest plane. So whichever plane it breaks na, that you always assume this is the systicity plane or the foliation plane. So follow this point na. So that is the. Now you can name this as S1. S1. Why I am telling S1? I will tell you. To understand this part now. Where the rock breaks, that is your S1 surface, S1 plane, or S1 foliation, or S1 systicity. S stands for systicity. 1 means fast. Now you see what I am telling. I will go to another thing. Yeah. Which one I will go? I will show you. Let's go to this one. No, not this one. The same photograph I am showing and I will show you something. After ये photograph को देखो. ये photograph, suppose this area I am just asking you. Is it clear? I will show you some other thing. Because since you are new to this type of things, look, let us see this one. Can you see the folds? Can you see the folds? These are the folds, you know. This is a fold. If just ask you which is the systicity plane, along which rock will break easily, that is the systicity plane. So which is the systicity plane? Can you just see? Should I enlarge it a little bit? बड़ा कर दिया किस तरह रॉक ब्रेक ऑलरेडी रॉक इज ब्रोकन कैसे रॉक ब्रेक करेगा व्हिच प्लेन इट विल टेक इजीली you see this place or this place you see this place you see you cannot see vertical yes so these are the surfaces you know these are the surfaces rock will break easily ऐसे निकल जाएगा this piece will go out understood na so that is your systicity plane this is the systicity plane which is the most weakest plane is in the rock in systicity or the foliation plane or S1 this you should remember understood na now I'll show you one more photograph. You see this one already I showed. This one already go back again. So which is the systicity plane you see? Suppose this part you see, along this rock will break. If you break it, it will go out like this. If you break it, it will go out like this. Can you see now? Now I will just come to this area. This area. A big line. What I am drawing, you just see. Drawing a fold, just see. When you see this thing, you see here, it goes like this, goes like this. From here it goes like this, it goes like this. Can you see this part? Like this? And where are those systicity planes? Systicity planes, I'll give a different symbol like this. And inside also you find, you know, if you sit down, you go like this, go like this, go like this, go like this. And outside also you see, you come this way. There is a big fold here, and how is the systicity planes? I'm not exaggerating, Whatever is there, just I am drawing carefully. You see it going like this, taking a rotation like this, like. Understood, na? The drawing is to understand. Now, my first question: on what surface the folds are developed, or which is the plane which is folded, which is the surface or which is the structure which is folded? Now, see, these folds are developed on this surface, na? This has been folded. So foliation has been folded. S1 has been folded. You understand this part why I am telling this? Because the weakest plane is your S1. That you always assume to be correct. वो बात में समझेंगे क्यों ऐसे हम बोल रहा. Suppose in the microcyst country you are working. Lot of cystocytic planes will be there. Calcyst country you are working. Lot of cystocytic planes you know. And you put your hammer wherever it breaks, you know, the way it breaks. That is your cystocytic plane or the foliation. That you are assuming to be correct. So that is called S1. That is the S1. So here whatever folds we are finding, this fold. So which is folded? The S1 surface is folded. Follow this point. Na? This S1 surface is folded. Is it okay? Good, huh? Now, if the S1 surface has been folded, these folds are second fold, third fold, कुछ भी हो सकता है. And just then we will discuss what is second fold, what is third. The S1 surface is folded. It could be a second fold. It could be a third fold. So it means this S1 surface has developed or is developing during F1 fold. I don't understand this logic. Because unless you understand this part, na, see this fold you are getting, you know, it is developed on, or it is folding developing a fold which cannot be F1 fold. The first fold in the area, it just cannot be this fold. So the folds which you are seeing may be a F2 fold, maybe an F3 fold. How it is F2, how it is F3 we will discuss later. But you see these folds are not the fast fold because the S1 plane is folded. Follow this point. So these folds are either F2 or F3 folds. हम decide करेंगे whether it is F2 or F3. But definitely it is not F1. That you मान के चलो. Understood ना? Now then you see. You are seeing a set of foliation planes. These are set of foliation planes or cystocytic planes which has been folded. These are S1 planes which has been folded. S1 planes you understand now. This has been folded. Now these S1 planes, how it is defined? You see. The mica has been digitalized, quartz feldspar has been digitalized, like this na. You see. Like this. See S1 planes. If you just take a sample from here and see under microscope, you will find all those needles, biotite, quartz, feldspar, all those minerals are aligned parallel to this, and they have been folded. Now, these minerals they are aligned this way, so they are defining this S1 plane. So now point is, how this hysterosity plane developed? How is this hysterosity plane developed? Understand the sequence, I'm just going in a reverse order. If you see a fold present on the foliation plane are very easy to identify in the rock. Very easy. Somebody has to show it that sir. And if you have a hammer, you can easily identify it. If suppose you are finding a fold on it, say it could be F2, it could be F3, it will not be F1. No. Now, this hysterosity plane is developing how? By the alignment of these crystals, alignment of these minerals. Alignment of these minerals. Understand up to this point. Now, how this alignment could take place? Suppose this rock, originally this was not folded. Original rock was a paletic cyst. Original it is same. Suppose originally it was a same. So let us come back to the original state. Suppose it is a cell. सेल में क्या होता है? सेल में you will find some very thin a siliceous band. Then there will be biotides, this side, this side, this side. Biotides will be there, clay minerals will be there. Then there may be another siliceous band. Have you seen a cell in the field? So this will be a siliceous band again. So then there will be biotides and clay minerals, feldspars, like this. So this was the original rock, which will give rise a rock of this nature. So this rock, when you fold it, how this will be folded? Then all these layers, they will be folded like this. This layer will be folded like this. This layer will be folded like this, and these minerals, they will be all aligned this way. See, the siliceous layer will be folded, and this matrix, you can say this is a matrix, and this is a competent band or layer. So competent band will be folded into a fold, and this will develop this type of minerals. So biotite, other minerals, they will crystallize like this. So what you are observing, this is histosity. This is histosity. Yes. Understood, na? And this fold is an F1 fold. This fold is an F1. So from a almost original or virgin rock, you are giving a compression and you are developing a fold. Simultaneously, you are developing this histosity or the foliation. So this fold, F1 fold and this histosity, they are simultaneous or synchronous. Follow this point, na? You just see this photograph, huh? Again you see this photograph. See. What you are observing, you see these folds. I was telling about this fold. Now see this fold. See this fold comes like this and goes like this. Another fold goes like this and comes like this. Can you see this part? Huh? I will draw it. Yeah. How? You see those? Start dividing. ऐसे जाके ऐसा है. When you see these folds now, they have been bent now. You see? It goes like this, like see? It goes like this, comes back, again from there it goes like this and goes out, and like this. Just like this. These folds, they have been modified to this form. And what about these hysterocytic planes? They are inside this. You see? They are inside this. See this part now. So these folds are F1. These are hinge folds. They are F1. This is F1. You see? This is the first fold now, and this hysterocytic plane is developing during that time. So this is the first fold, and this hysterocytic planes have developed. Just compare these two figures. Here the folds are bent, but here it is not bent. Just at the beginning. That is why this feature and this feature they are matching. So these folds are fast folds because this hysterocytic plane is also developing during that time. So this is the F1 fold, and these are the S1 cleavage or S1 foliation, cystocity. The similar words, cleavage, cystocity, foliation. Understood this part or not? So now if I just ask you, what is this fold? F1 fold you will take. What is this cystocity? S1 cystocity. You don't understand this part or not? And suppose I say, what is this fold? This fold. This will be F2 or F3. Subsequently it is developed. Because this hysterocytic plane is folded. Later on what will happen? This hysterocytic plane will be folded. This hysterocytic plane will be folded like this. So there have to be second fold or third fold, whatever name. You don't understand this part. Tell me.
In above here, there is cystocytic plane are also folded
With this siliceous layers.
Here I get this is the F2 fold, no?
This is F2 fold. These are the F2 fold. Yes, F2 fold. Yes. Like this. But what about this? This is F1. This is F1. Understood or not? Tell me. Huh?
Sir, during F1 folding, fast phase folding, cystocytic planes are only developed, not folded.
Not folded. Only developing. Before that, its hysterocytic plane was not there.
Then why stress are synkinematic?
Synkinematic means same time. Fold is developing and cystocytic plane is developing. That is why I call it synkinematic. Kinematic means what? Movement. Understood, na? But suppose I ask this question in opposite way. How to distinguish a F1 fold from F2? Suppose I ask this question. How to distinguish a F1 fold from an F2 fold? Understood my question? Huh? How to distinguish an F1 fold from F2. So this question comes from me. Yeah. I went to field, I saw so many folds, whether it is an F1 fold or an F2 fold, how to distinguish? What would be the answer? Tell me. F1 fold will be? Cystocytic plane will be parallel to its axial plane. Is it that? Cystocytic plane, is it cystocytic plane? इसका जो axial plane है, उसका साथ parallel जाएगा. What is F2 fold? F2 fold will be like this. See, again so. Unless I clear this point, there is no point. I cannot teach the interference pattern. Let us see this fold again. This way. So which is the cystocytic plane? Cystocytic planes are this now. Yes, again. This is the S1 plane. That is your starting point, S1 plane. Why we say it is S1 plane? Because rock breaks very easily along those planes. Because they are very penetrating, very closely spaced. It is developed due to crystallization of micas. That is why it is S1 plane. The most penetrative cystosity is called the S1 plane. ये आपको remember करना है. Understood ना? Now this cystocytic plane is going like this ना, ऐसे ऐसे करके ऐसे करके. So this cystocytic plane is folded. Folded means what? ये fold develop हो गया. These are the folds. So this fold has to be an F2 or F3. This cannot be F1. That you are ruling out. This cannot be F1 because cystocytic plane is folded. Cystocytic plane पहले develop किया है. So during which fold or which folding time the cystocytic plane developed? Understood this logic? By a previous fold. So now you come to this picture. This one I have drawn first. These are the cystocytic planes. So here this cystocytic planes and its axial plane, they are all parallel because the cystocytic plane is developing parallel to S1 is developing parallel to the axial plane of the first fold. You understand this point or not? The cystocytic planes are developing parallel to axial plane of the first fold. Because during folding the cystocytic plane is developing. So wherever you will find a relationship like this, the fold axial plane is like this and cystocytic plane is parallel to it. So that is in F1 fold. Now suppose take this fold. Which fold? Let us take this fold. This fold. ये fold है. ये वाला हम करें. ऐसे जाके it is meeting. Its axial plane will be like this ना. You see the outside cystosity will be like this. Suppose this fold, this fold. Its axial plane is like this, axial plane. So outside cystosity is also like this. But if you see this fold, whose axial plane is like this, cystosity plane is bent over it. Follow this logic. Why that is an F1 fold? Why this is an F2 fold? This is to be understood. Suppose you see a photograph like this, immediately you see which is the cystocytic plane. This is the cystocytic plane. So this is folded. That means this is a left fold. F2. F2 fold. Which is an F1 fold? You see a fold where this cystocytic plane will be parallel to its axial. Understood this part? So that is an F1 fold. So the distinction between the F1 and F2 is with respect to the S1 plane, S1 cystosity. If S1 cystosity is parallel to its axial plane, it is an F1 fold. If S1 cystosity is folded, that is a F2 fold or F3 fold, subsequent folds. The point समझा कि नहीं समझा? I will show you another photograph. You just see. I am not leaving this part unless. Let us see some other fold. You see these folds. Which is the cystocytic plane? Can you just check here? Which is the cystocytic plane? Suppose you break this rock, you see break. यहाँ से टूट जाएगा ऐसा सब. यहाँ से टूटेगा ऐसा. So this is the S1 plane. These are the S1 planes. S1 planes will be like this. So what will be this fold? F1. Because इसके axial plane जो है, इस cystocytic के साथ parallel है. That is why it is an F1 fold. Understood this part, na? Very easy. Somebody should show it. आपका blood pressure मापा मैंने, मापा आपने, blood pressure कभी नहीं मापा. Very easy to measure, but doctor will not tell you. आप जाएंगे तो उसके पास भी. ये बात है. So only somebody he teaches you how to measure. He will tell you very difficult, very difficult things to measure. Like that, So unless you see somebody shows you, why this is the fold, like cutting, you see the XL plane and system plane, then it becomes very easy. I will show you one more photograph. Can you tell me what is this fold? I will not ask what is this fold. Can you see the sister plane? Sister plane, आप यहाँ ब्रेक करो, किधर ब्रेक करेगा आप? ऐसे ऐसे ब्रेक, see the plane, ये weak plane है, ये सब weak plane है, ये सब weak plane है, ये weak plane है, ये सब weak plane है, weak plane, weak plane, weak plane. Rock will break from here ना, so these are the sister plane. ये. See what is happening to this sister plane? ऐसे जाके मोड़ के ऐसे आ गया, ऐसे जाके ऐसे मोड़ के आ गया. Can you see ना? Very clear. So what is this fold? F2. You see, you have become master now. So this is an F2 fold. Suppose somebody asks you why it is an F2 fold, because S1 plane is folded. S1 plane is fold हो गया. समझे कि नहीं समझा? So very easy now for you to identify F1 and F2 fold. और एक देखा था आपको. अब देखो. सिस्टम प्लेन आप देख सकते हैं क्या? हाँ देख सकते हैं कौन सा सिस्टम प्लेन है? ऐसे ऐसे रॉक ब्रेक करेगा, ऐसा ऐसा. अब देखो ऐसे जाके ये फोल्ड हो गया ना, इस दफा कैसे फोल्ड हो गया. देख रहे हैं? तो व्हाट इज दिस फोल्ड? इधर एक फोल्ड आप देख रहे हैं इधर F1. A non-geologist also become a geologist. ठीक है? So okay. What is an F1? What is an F2? The concept to understand na. Why you will bring F1 and F2 into picture? When we will discuss the interference data. That is the purpose. F1 fold is produced first time in the rock. F2 fold subsequently. So F1 features will be modified by the F2 features. That is how interference pattern will be produced, a hybrid pattern. So this is an F1 fold, this is an F2 fold. Understood now? Now you see, I will show you. I am able to. This is a thin section photograph. You can see that this is thin section. Suppose I ask you which is S1. S1 कौन सा है? ये सब है ना, ये सब देखो कैसे S1 है, S1 है, S1 है. अब यहाँ कोई बोलेगा आप रॉक ब्रेक करो. ये रॉक को. Naturally यहाँ से flex. See the flex will go out like this. यहाँ से मारोगे आप, हाँ मार. That is why the miners, the mining people, they say it is a slatty cleavage. S1 cleavage is called a slatty cleavage because rock breaks thin flakes. So most of the slate miners, they use this plane. This is S1 plane for mining. The most closely spaced, most penetrating, most closely spaced. Space. Penetrative. Penetrative, you are understanding that? Every inch, every centimeter you will find a plane. That is called penetrative. A fault is a penetrative feature, a hystericity is a penetrative feature. A fault is a penetrative feature or a hystericity plane. S1 plane is a slatty cleavage is a penetrative feature. Slatty cleavage is a penetrative feature. Fault, it is not penetration. It is how closely they are, everywhere they are present. That is called penetrative feature. Everywhere it is present, you see. That is the definition of a S1 cleavage, S1 system. So I ask you, what is this fold? Fold you can see now. What is this fold? F2. Very good. Or F3, later generation folds. Understood ना? It cannot be F1. F1 होता तो F1 ऐसे नहीं होगा, क्योंकि इसके साथ parallel होकर F1 होगा. Parallel to this plane. If there is an F1 fold in this rock, its axial plane should be parallel to this hystericity plane. You understand this point? No? So these are F2 folds. F2 folds axial plane, you see. Follow this point, no? So this has to be an F2 fold or F3 fold. Now these folds, F2 folds or F3 folds, are also called as granulation. Granulation. F2 folds or F3 folds are also called granulation. I'll come to that point. What is called a granulation? Granulation. So it could be F2, it could be F3, but F1 cannot be granulation. Remember. Can you tell me why? That is, from there the definition of granulation comes. F1 fold is not a granulation. F2, F3, they will be granulations. So what is the difference between a fold and a granulation? Granulation is also a fold, but all folds are not granulations. That is what. I will come back. But you remember this photograph, but I will go back to somewhere and come. The previous photograph I will go. You see this photograph also. You can see this photograph. Can you see this hystericity, S1 hystericity? So what is this fold? F2 only. See everything is folding, right?
The lower part is F1.
Huh?
The lower folds are F1.
No, there is no F1. Where you are telling me where? Where?
These are very much.
These are? No, these are all F2 only. See, this is very large fold. Aisa. All F2 folds. Which one you are telling, pointing out? No, these are all F1, F2 folds. Okay, na? We will come back. We will come back to this photograph again. ठीक है ना? So which is an F1, which is an F2? Now you understood ना? This is an F1. ये जो fold आ रहा है, ये हो के ये घूम के आ रहा है, ये F1 है. But this fold, ये fold जो है, open, broad fold, ये broad fold. These are F2. Understood ना? So this is a granulation. F2 is a granulation. F1 is not a granulation. That is what, na? F1 is not a granulation, but F2 is a granulation. You understand this part, na? The F1 fold which you see here is not a granulation, but F2 fold which you see here is a granulation. Granulation is a fold, definitely a fold, but all folds are not granulation. Follow this point, na? So granulations are those folds which develop on hystericity plane. Remember, cleavage plane, foliation plane. They will produce granulations. तो उसको तो हम डिस्कस करेंगे. But now the F1 fold, where it is there? You see, अब तो पहले रॉक जैसे था, सेल था. It was a cell. Where there are siliceous bands are there. These are the matrix. These are the siliceous bands. Here there was no hystericity plane. Initially there was no hystericity plane, no cleavage plane. So the folds are developing on the bedding plane. This is the bedding plane. Bedding plane or bedding, you know. So this bedding is developing these folds. First time you are developing a fold. So this fold is developing on a bedding plane or bedding. That is why it cannot be a granulation. Now you are developing cystosity over it. The minerals are crystallizing like this. Na? So now the folds will develop on this cystosity plane. That is why they are called granulations. Understood? Na? So these are granulations. So now we will discuss something more related to granulation maybe in the next class. But you see what the distinction between the F1 and F2 folds. F2 folds are granulations. F1 folds are not granulations. F2 planes develop on cystosity planes, slaty cleavage. So these are the distinctions. But the F1 fold develops on the bedding plane. You can write F1 fold develops on the bedding plane. Bedding. So these are some of the points which distinguishes F1 from F2. समझा कि नहीं समझा? अच्छा. Now you see how a granulation look like, yeah? Again we'll go back to that photograph. Huh? You can see the granulations now. So these are the S1 planes. S1 planes. Understood this part now? S1 is folded. So these are F2 folds. So these are granulations. Now can you see these fractures? ये fractures देख रहे हैं ना? हाँ? You see these fractures? I'll show you bigger or distance view. Can you see the fractures? So these fractures are associated with the granulation. ये फ्रैक्चर को क्या करेंगे आप, क्या नाम देंगे? These are granulation cleavages. So these granulation cleavages are developed during F2 folding time. ये cleavage है ना? Rock is breaking here ना? So see, this is the axial plane of granulation. Parallel to this, it is developing. A fracture is developing. Parallel to granulation axial plane, this is developing. So this is a granulation cleavage. So, ऐसा. Very big fractures will develop, like this, parallel to axial plane of the granulation. So these are called granulation cleavage. Granulation cleavage. You understand the meaning of granulation cleavage? Fractures develop parallel to axial plane of the granulation or F2 fold. Is a granulation cleavage. So you can name it as S2. S2. So now you may ask you, what is this plane? S1. What is this plane? S2. कोई आइडेंटिफिकेशन में कोई गलती नहीं होगा. Understood ना? Because once you know it is a granulation, this is a granulation cleavage. So this is a slaty cleavage. Slaty cleavage. Because rock breaks very closely, but this is not a penetrative feature. Widely spaced, na? Widely spaced. But this is a penetrative feature. S1 is a penetrative feature. S2 is not a penetrative feature. It's just like a fault, Fault. ये यहाँ डाई आउट हो गया, देखो. It's not grounded. कहीं है, कहीं नहीं है. It is not a very penetrative feature. You see some other photograph? ये देखो. Can you see? Just like a fault unit, it has displaced these two units. Granulation cleavage. कहीं है, इधर थोड़ा है, इधर थोड़ा है, देखो. See some other photograph? इसको देखिए. You see the granulation cleavage and granulation. You see these are the granulation cleavage. छोटे inside these there are granulations. Can you see that? Huh? So this is S2. This is S1. ये सब S1 है. Understood ना? So this was S1, S2, F1, F2. So next class you will understand this interference pattern. Huh?